Sigma notation, very patterny. Generally, it kind of confuses people when they first see it, but once you see kind of how things are playing out, it clears up quickly, I think. This is a Greek letter sigma, an S, and we use the S for summation, sums, adding stuff up. So what this is a compact way of writing a bunch of things added up. How do we use it? Notice that this letter matches that letter. That is not an accident. These are three different examples. See, these match. This is what I start plugging in for the K. And what I do, it's called an indexing variable. So what I do is I plug in 1 for K, then I plug in 2, then 3. I do all the integers. 1, 2, 3, 4, 5. And how do I know when to stop? Up here. This is start, this is stop, and I only do whole numbers. So what I do is I plug 1 in for K. This is a summation. And I add, and now what I'm going to do is I'm going to plug in 2 for K. And then I'm going to plug in 3 for K. And then I'm going to plug in 4 for K. And then I'm going to plug in 5 for K. And then I'm going to plug in 6 for K. And then I'm going to stop because it says stop at 6. See, this is K equals 1, K equals 2, K equals 3, 4, 5, and 6. And then all I've got to do is add those all up, and that is my summation. So that'd be 10, 21. That is the answer. This is just showing you how we get the answer. All right, let's try it with a little more clutter going on. See the K, see what's happening to the K. So I'm going to use two colors here. So I'm going to let K start at 2 and end at 5. So first, I'd have 2 times 2 plus 3 plus 2 times 3 plus 3 plus 2 times 4 plus 3 plus 2 times 5 plus 3. Stop, because it said to start at 2 and end at 5. And see, all I'm doing is doing that every time, starting with 2, ending with 5, and doing every counting number. That's the expansion, that's the work. My actual answer is what I get when I add all that junk up. So let's do that. This would be 4 plus 3 is 7. This would be 6 plus 3 is 9. 8 plus 3 is 11. 10 plus 3 is 13. So this would be 20, 30, 40. So that answer is 40. How about this one? Well, now I have a K squared. So I'm going to have, let me do it this way. So this would be starting with 0 for K, right? That's that with 0 plugged in, plus that with 1 plugged in, 2 plugged in, 3 plugged in, and 4 plugged in. And I'm only drawing these underlines so you can see it's the whole package every time. And all I'm doing is in place of the K, I'm plugging in whatever it says to start with, and then I index it up by adding 1 every time until I hit the stop. Then I just have to add that all up, and that's my actual answer. So this would be 0 minus 3 plus 1 minus 3 plus 4 minus 3 plus 9 minus 3 plus 16 minus 3. So that would be minus 5 minus 4 plus 2, grand total plus 15. That is my answer to this problem. Okay, so that is how you expand out these sigma notations. Now, sometimes you get really big numbers and you're not going to want to do this. And for that, there's formulas. If these are small numbers, it's probably easier to just crank it out by hand. But if they're big numbers, we have formulas. Now, on the test, I will let you use, I'll attach to the document the formula sheet. So you don't have to memorize these, you just have to know how to use them. So let me list the formulas first. See how I put an N up there? That means instead of stopping at 6 or 5 or 4, it could be 100 or 1,000 or whatever I want to put there. Okay, that's that one. And there's that one. So we have these three formulas. There's actually kind of a fourth one. K equals 1 to N. If you have a constant, so I'm going to use A, then it would be N times A. So there's really 4. Now, we're going to have numbers, like see how that's just K cubed? What if I have a 2 in front of there? We'll have to talk about that. But let's just do a basic 1 or 2 to see how these work. Let's say I ask you, what is the sum as K goes from 1 to 43 of K squared? Okay? So instead of going 1 squared plus 2 squared plus 3 squared all the way out to 43 squared, we can cut to the formula. See how, this formula, the K squared. So what does it say? N. This is not an accident. This number is N. So this is going to be 43 times 43 plus 1 times twice 43 plus 1. Let's see, that'd be 86 plus 1. 2 times 43 plus 1. All divided by 6. And whatever that is will give us the same answer as if we did that all the way out to 43. So let's see, 43 times 44 times 87 divided by 6. So I'm getting, that is not correct. Let's see, 43, 86, 87, 44, okay. 43, 44, divided by 6. There we go. So I'm getting 27,434 is the sum. Okay, let's try one of these. As K goes from 1 to 29 of K cubed. All right. Well, what's the formula say? Well, I have this shell, and see the ends here. So I'm going to have 29 times 29 plus 1 would be 30. So order of operations says I got to work out in the parentheses first. 29 times 30 divided by 2. And then I got to square it. So I'm getting 189,225. Now let's see like a full-fledged problem. We'll do like 3 of those, and that should do it for this lesson. All right, let's try the sum as K goes to 1, from 1 to 58 of 3K. Okay. So my formula didn't have that 3 there. So kind of what we do is we expand this out. So you can pull that 3 in front. See? And what that means is I'm just going to do what I did with the formula last time. and just times it by 3 when I'm done. So the number in front of the k or the x or whatever variable you're using, you kind of ignore it and then just multiply when you're done. So our formula said n, which would be 58, times n plus 1 is 59, and we divide that by 2. So if I punch all that into my calculator, that would be my answer. Times 3, 5,133. Okay, the next one, this is how I would break it up. K equals 1 to 64 of k squared minus 4 times the sum. So look at that for a second. What did I just do? I separated, like if it's the sum of both these terms, I kind of just wrote the same sum of each term separately, and I just pulled all that clutter, the minus 4, in front, right? So this is, I wrote that as a second summation, and like I did up here, I just pulled the 3 outside of the sum. I pulled the minus 4 outside of the sum. How would I do that here? This would be the sum as k goes from 1 to 100 of this, but I'm going to pull the half out front. Then I'm going to have minus the sum as k goes from 1 to 100 of 3. So that's just a constant. There's no k there. Let's see how we'd work this. This is a straight out formula. So this one was n times n plus 1 times 2n plus 1 divided by 6. That's just this part. Minus 4 times, now I'm going to do the one for regular k, which is n times n plus 1 divided by 2. And now I just have to carefully punch that in. So let's see here. 64 times 65 times 129 divided by 6. Minus 64 times 65 over 2 times 4. And when I subtract these, I get 81,120. So that would be the answer to this problem. Third one, this is how I break it up. So I'm just going to focus on this. It's 1/2 times n times n plus 1 over 2 squared. That's just this part. Here's this minus. And this was the first formula I added up at the top when I wrote 3 and I said, oh yeah, there's one more. When you have a constant, all you do is multiply that number times this number. So now I have to be careful. So I'm going to work from the parentheses first. 100 times 101 over 2. I'm going to square that. And then I'm going to multiply by a half. 12751,250 minus 300. So my final answer for this problem would be 127,50950. All right, I know those can be a little weird in the breaking apart. Let me just erase these first two, and without doing the full problem, let me just show you how you break some apart, and then you can kind of play with the formulas. I think the formulas aren't bad if you can get how to break them up. So let's try somewhere we're just going to break them up. Okay, so let's try these. Technically, I should put those in parentheses, I guess, but we're just going to break these up. let's start with this. There's one less term. So focus on the first term. Pull that coefficient out. So it's going to be 1/2 times this structure here, k squared. Then -5. Then we need the summation stuff again, same numbers, of just the k. See, I'm trying to strip the k's from the numbers. Plus a constant, so I'd write it like that. And then I would use the formula for this and then times it by 1/2. The formula for this and times by -5. The formula for this one where it's just 59 times 7. Add them all up. That'd be my answer. Excuse me. Let's try this one. It'll be a little longer. See the 3 there? So I'm going to have 3 summation k cubed. See the -2? -2 summation k squared. See the +5? +5 summation k. And then I have a constant, a just number, so that'll just be plus summation 1. So this would be 3 times that formula, minus 2 times that formula, plus 5 times that formula, plus 105 times 1. Add them all up, and that is your answer. By the way, many calculators will do summations, so you can try to look at that also. But these are the formulas, and you can get the answers by using these. All right, practice the homework. Summations are not bad at all once you get used to the notation, but you do got to get used to them. Take care.